The next section is on electric resistance. It's section 25.2. As most people understand, current will find resistance in trying to flow through an object. And that's true except for superconductors. And so we can say, how much resistance do we have? Well, when we take this object and we put a voltage across it, here again is our battery with a voltage V, and here's our substance. If we put a given voltage, say 12 volts, across this object, we might get a current I to flow, but if we put that same voltage across another object, we might get 2 or 3 times that much current to flow. The ratio of the current that flows to the resistance is called the resistance. The ratio of the current to the voltage is called the resistance. And that ratio is constant. That was first discovered by Ohm, and it's called Ohm's law. Mathematically, we state this way. We say that if we take the voltage and divide by the current, that is, we take this in volts, the voltage here, and divide by the current in amps, then we will get the resistance, R. And for example, on our 12-volt battery, if we got a current of 2 amps, then we would see that our resistance would be our 12 volts divided by our 2 amps, or would be equal to 6. And the unit for this is called the ohm. That is a volt per amp. Let me take this current out and just write the amp here. And this is an ohm. And the symbol for an ohm is the omega. So 1 ohm is when 1 volt is applied to a substance and it causes a current to flow of 1 amp. We normally take the current and multiply it by the resistance and write this in a new way and write voltage is equal to resistance times current, saying that the voltage is proportional to the current and the constant proportionality is the resistance. So this is a volt, this is an ohm, and this is an amp, or an ampere, or volt, ohm, and amp. Now, if we take different series, like with capacitors, we can connect them both in series and parallel. If we take resistors, and the symbol for a resistor, incidentally, like this resistor here, looks like this. It's a zigzaggedy line. So if we take a resistor here, and then we add another resistor, and then add another resistor, and if these have resistance, R1, R2, R3, and so forth, then we can ask, what is the resistance of this entire object here? Obviously, the current has to go through this one, then this one, and then this one, so the current's going to be greater. I mean, the resistance is going to be greater. Well, it turns out that if they're in series, as I have written here, it's simply R1 plus R2 plus R3. It's the simple sum of these. If, however, they're connected in parallel, so that we have a resistor here, and a resistor here, then in fact, if this is R1, R2, and R3, then in fact the resistance of this whole object is given by a formula that's very different, but it's reminiscent of the capacitor formula. 1 divided by the resistance of the whole system is equal to 1 over R1 plus 1 over R2 plus 1 over R3. If our resistors here had values of 1 ohm, 2 ohms, and say 4 ohms, then we would find our total resistance of this system to be 4, 5, 6, 7, the simple sum of these. so we would get 7 ohms. But, however, if we connected these as a resistor of 1 ohm, 2 ohms, and 4 ohms like this, we would find our equation look like this. 1 over the resistance in parallel, this is series, parallel would equal to 1 over the first one, that's 1 over 1 plus 1 over 2 plus 1 over 4. And this has a common denominator, which is the same as 4 over 4 plus 2 over 4 plus 1 over 4, or 4, 5, 6, 7 over 4. So it's 7 over 4. But don't forget that this is the reciprocal of the resistance. So the resistance in parallel is going to be given by 4/7 ohm. You'll notice here that this is less than any one of the separate resistors. And that's because if you look at this parallel system, this resistance here is less than any one of these because the current can choose to go through here, here, here. It's like a pipe where the water can go here, here, and here. So the pipe is larger by having these things in parallel. Whereas here, it has to go through one, then the second, then the third. So pretty much that tells us how we compute that. I might give us a problem. You might want to think about how do you work a problem like this, where I'm asking for the resistance of the whole system. I'll give you a hint here. The first thing you do is reduce these two down to 1, and they are in parallel, so you use this formula here. Then you take that result and use it in series with this one here and add those two together, and that would give you the resistance of this whole system. The key things to remember are this is Ohm's law. The form that we normally use to memorize it is here. And a volt is equal to ohm times an amp. And we have two laws, one for adding up the resistors if they're in parallel, and another one for adding up the resistors if they're in series. So these are the key things you have to remember. The series equation, the parallel equation, the fact that this is an ohm of resistance, and the V is equal to R times I.